So real quick here, and let's see if we need to talk about anything else here. So I wanted to just talk about just grades. So last week on the 10th, I thought grades were due on the 15th, so I pushed to get them done. Pushed you guys to get them done too. So real quick here, check your grades in Google Classroom. Whatever your percentage is, that's your percentage in the class itself. Are we good? If you see anything that's really, really wrong, I had one student come up. I put a 2 instead of a 3 for 20 or 30, and that kind of affected her grade. So if you see something just totally off, come talk to me. I do have to turn in grades tomorrow, so kind of make sure that it's done by then. Just email me. Okay, we're good there. Jumping to, how's you guys' week? Like the same has you for a whole week. Yeah.
Pretty much nothing.
Since it's a 4-day weekend, anybody do something fun, exciting, Abe?
I walked in a straight line at 11 o'clock.
No way. That normally does not happen, correct?
No, we
Okay.
literally just started walking in a straight
Put
line for
the
like an
traffic
hour and a
cones
half.
in the middle of the street in the dark.
Yeah, I'm still thinking that was a bad idea. Oh, okay, shut up.
Okay.
I made a post on Twitter that it was up for an hour because I had to take it down. I opened myself to coding commissions. And I got 73 requests within an hour, and I had to close it because that is a ridiculous amount of requests to fulfill. And I ended up accepting like 20 something of them. And it filled my weekend.
Request, like someone wants you to
Like
write code?
someone wants to give me money to code them something.
Okay, gotcha.
And it was ridiculous amounts, and I was coding for 20 hours this weekend. It hurts my soul. I'm not doing that for like another month or two.
Okay. You asked for work, you got work.
Oh yeah. On top of actual work, on top of school. work.
What did they want you to code? For
Anything from games to simple programs to just ease of use functions for computers, changing certain programs, just really anything that involves like, hey, you're a coder, can you do this thing? And then I can say, I can do that thing. They're like, I can give you money for that. I'll take your money. I don't make that.
You give me money for a code you make, like, I'm so down.
Right?
He makes it better. I get the company that produces.
It's business. That's how it works.
My man already started contracting business.
Exactly. But it hurts when you get that many in an hour.
Gotcha. Okay. Anybody else besides having a whole bunch of work to do? We're getting paid for it. That's cool too.
Money's good.
That's awesome.
Especially because I can pick my own rates. Very nice.
Very true. All right, class, let's begin then. Let's begin with the good old algebra here. All right, we good? Chapter 2. We finally got to chapter 2, and we're going to go a little faster here. So let's go with chapter 2. Am I recording? I just make sure yep. Okay. Chapter 1. Let me go back to chapter 1. Chapter 1 was about functions, right? How to deal with functions. Add them, subtract them, transform them, right? Oh, and then we did something called composition, right? One function inside another, right? So we're going to stop that for a while. Chapter 2, and we're going to keep on going. It's about polynomial functions and something called rational functions. Okay, so this is going to be sort of like the end of factoring for us. You guys have finally come to the end. We're going to try to find zeros of a polynomial function. We're going to have these different ways to do so. So factoring works for x squared, right? The question is, what happens if you go x cubed, x to the 4th, x to the 5th? How do we handle that stuff? That's the question that we have here. And then the rational functions are fractions, right? Something like this. Right, over something like that. Are we good? Those are rational functions. Don't need to write that particular thing down here. But let's go with it here. We're going to learn something new. I think it'll be kind of fun. So 2.1, quadratic functions and models. I'm going to erase this little part right here. So boom. we're gonna do some graphing here as well for a little bit. So quadratic functions here, something that has x squared next to it. Let's do a whole bunch of stuff with x squared. Eventually learning how to graph the connection between graph form and seeing how we can graph them quickly here. So we want to get that connection first. And then we'll go from there. So first things first is a graph of x to the second power. Or we should say f of x to the second power here, since we're going to deal with functions here. So I'm going to go like this. And let's start dealing with that one. So talk to me. I think this is how we graph it. We go like this, right? It hits 0, 0 right here, and it bounces back up. So the points that we think it's important to go through would be 0, 0. Sometimes we call critical points. We have the point 1, 1. And usually we label 2, 4, right? Because 2 squared is 4, and we're good to go. And then the other way. So the -1, 1, -2, 4. Now, do we need all those 4 points, all the 5 points all the time? Not really. Just as long as we have a good measure of, we probably need at least 3, because we want to know how steep is the graph, right? Or how wide is the graph? Okay, so let's go with it here and build up some stuff here. That's that one here. So based upon that, my question to you guys is, can you graph for me? I don't want to do it by, and graph for me f of x squared is equal to 3x squared. Which one, Owen?
What we're supposed to be graphing.
3x squared. So graph f of x is equal to 3x squared. Is it just too light or no? Are you guys okay? Can you guys see that? Camille, from the back, can you guys see the board or no? Okay.
I'm blind, okay? My mom's gonna make me look in my eyes, Jeff. That's not important.
I got an awesome desk for you right here.
Yeah, no.
All right, so talk to me. What do you think that 3 does?
Except thinner.
Yeah, we could say thinner, or we could say
It makes it more extreme, right?
More compact.
compact. I like that because you guys are thinking of squishing it, right? We just say it makes it more steep because it just goes up faster. Right?
Oh, that makes more sense.
That's cool. So can you graph for me the 5 points? I think we should still do 5 points here. So the graph should be a little more leaner, right? It's gonna go like this right here, and then it's gonna come up, and then it's gonna go back up like that. Still, it should be a U, right? Just a very squished U. So don't make it a V shape. Make sure you have that little edge at the end there. Okay, 0, 0 still there. Now this guy here. So notice originally, let's go back to the original one here. Notice originally when we go out to the 1, right? Then what we do is we go up 1. Good there? Notice when we go out to the 2, we go 2 this way. But then what we do is we go up 4. So the connection is 1, 1, 2, 4. We good? This one, because we have that little 3 there, we are going to go 1. And it's almost like this. It's going to be 1 squared. That's how we get the 1 multiplied by 3. So this little dot should be now 1, 3. Are we good? So everything is going down 3 times faster here. So if we go like this, you guys talk to me here. If this is 2, how much do we go up? Sure. Let's see. Does that help a little? Thank you, Abe.
How going to walk?
Why are you looking at me like that? What did I do? I showed up to school.
That is good. That is good. Okay, go for it, guys. So in this case, what we're gonna do is we're gonna say 2 times 2, which is 4, right? Multiplied by 3.
It's 12.
It is 12. We are going up 12 now.
We
So-
didn't know we just said 4. How did we get 12?
You just multiply by 3.
Yeah.
No.
So 2 comma 12. Okay, the other side, same thing. If you go off to the left side, Dylan.
So we're doing 3 times x squared, not 3x squared, right?
Or 3x squared is the same as 3.
Well, no, we're doing 3 times x squared.
Yeah, we're doing 3
not-
times x squared.
okay.
Yeah. Dylan had a quick question here about this here. So the little 2 right here, that 2 is only acting on the x in front of it. If you wanted to act on the 3 and the x, you have to put in parentheses because now you're gonna hold both those in there. Okay, so -1 comma 3. And how about -2 comma 12? So this little multiplier at the end, really what's happening is that 4 we got by 2 squared and that 1 we got by 1 squared. So we square the side going up and down. Okay, one more graph for me. 1/2 x to the 4th. Or x to the 2nd, sorry. All right, this one, important. Again, the graph still goes like this. Comes in, ooh, you know, what do you guys say? It's gonna be a lot more wide, is that right? Because the 1/2. So I'm gonna take it out like this. And so if you want to write down on the side, this is what I usually do. I go 1 out and I say 1 squared times 1/2 gets me 1/2. 2 squared times 1/2 would give me 4. Just give me a 2, is that right? So I got myself 0, 0. As I go out to the 1, I'm only going to go up 1/2. As I go out to the 2, I'm only going to go up 2 this time. All right, and the other way here. So -1, 1/2. And how about -2, 2? Are we good? We're gonna get excited in just a little bit here. Okay, negative in front. What do you guys think? What does that do? Should we do one like that? I guess we should. Okay, are we good though? Everybody okay with it being going out 1 and then that little multiplier is going to give it. So you square however you go away. And then you multiply by that multiplier there. Okay, so let's do this one. I think we're ready for this. Graph for me. (1/2 x minus 3 squared). All right, let's see. The 1/2 is going to do what we did last time, right? But what's the minus 3 going to do?
It shifts to the right.
Oh, that's right. So, okay, we have a right shift of 3 units. And so now it's no longer 0, 0. We go 1, 2, 3. Now we have a little, we call this actually a vertex. It's very important, that little bottom of the graph. Sometimes the top of the graph is called a vertex. Okay, I think we're good now. So I'm gonna make this wider a little bit like this right here. I'm not sure where it crosses the y-axis yet. So question for you guys here. Can you graph for me the other 4 points real quick here? What would they be? So this guy now is called 3, 0. So that means we go out 1, is that right? We square the 1 and multiply by 1/2 gets me still a 1/2. Okay. Off to the side, we go out 2. 2 squared times 1/2. 2. So now this guy's going to be 4, 1/2. Then this guy's going to be 5, 2. Are we good there? Backwards, this is going to be 2, 1/2 right there. And this one's going to be 1, 2. And there's my graph. All right. Dylan, question.
So the 1/2 kind of like widens
Mm-hmm.
the model, right?
Uh-huh. Real quick here, why do we study parabolas? They are so important, especially in, let's say, business or physics. So this one right here, once we move this up, we model costs for a business. And that guy is so important because that tells me what's the lowest cost this business should run at. And so anything above it, I'm going to have extra expenses. We good? And so the parabola is, the only thing is, does it get more complicated? Yes, because if you're selling shoes, right? Talk to me, all the costs that involved in selling shoes. Raw material cost to make the shoe, right? You got to pay someone to make the shoe, right? You have to distribute the shoe, and you got to do endorsements for the shoe sometimes. And then the salesperson for the shoe, right? The box that it's in, yeah, packaging, which I'll say
The bits of paper that they fill the shoes with.
Yeah.
part of packaging, yeah.
The little
Put a
like,
security
on
tag
the
that
end
they
of the
place on the
shoelace is
shoes.
like a plastic cylinder.
Yeah.
So, okay, all those come in to make a cost function. And usually what happens is it's something like this, it's a curve. And so this little guy right here says that should be your lowest cost for the curve, if that's what you're trying to do. Okay, are we good there? Going back the other way, if you go this way, what you do is you talk about revenue for a company. That means you talk about what's the highest I can get for this shirt.
$75.
Maybe.
It's a good shirt.
My wife and I were shopping, and I just wanted to try, just for the fun of it, I tried on a $400 shirt.
Did you buy it?
No, but it was fun to try it on. It was
How much different did it feel than a normal?
it did feel that way. It was a white shirt, and it had this embossed stuff of a parrot
Ooh.
all across the back, and the tail went all the way down. It was kind of
It's
fun.
like a designer, like long sleeve shirt.
Yeah, it's a design one.
Nice.
And it was a tropical shirt sort of thing. But I thought it was kind of cool. I tried it out.
That's pretty cool.
Okay, so making most amount of profits. That's what we want to do here, right there. So that's kind of what we're looking at. So then, again, these little curves, that little top of a curve or bottom of a curve. It's so important we do that. Okay, let's keep on going here. I think we are almost at one part here. Can you guys graph for me? Let's do an easy one here. X minus 2 squared plus 1. All right, the minus 2 means we're going to go to the right 2 units. Up 1, perfect. Can you put that vertex where it belongs? And then from there, can you figure out the other 4 points? So that vertex, super duper important. In fact, in mathematics, we say the vertex is important if it hits the x-axis is important and it hits the y-axis. Those are the 3 main pieces. All right, I'm going to try it here. So 1, 2, then 1, it goes right there. And from here on out, I know it's going to go 1 up, or 1 to the side, 1 up, 2 to the side, 4 up. Is that right? Because there's no multiplier to it. And if we want to just kind of do the work here, it's going to be 1 squared. This is going to be 2 squared. So 1 up, 1 over, 2 up, 1, 2, 3, 4 over. So I got something looks like that. 1 up, 1 over. Oh, that's cool. It gets back to the y-axis. 1 up, or 2 across. 1, 2, 3, 4 up. Okay, label. Here it is. I got 2, 1. I got 3, 2. And I have a, what is that? 4. Thank you. 4, 5. Back the other way. I have a 1, 2. And I have a 0, 5. Boom. Are we good? Okay. How much time we have? Okay. I think if I put a number in front, I think you guys can do that, right? I think that's easy enough for you guys to do. Next is this little part right here. Our problem is the fact that, oh, let's do this. This is called a standard. So standard form of a quadratic function. So standard form of a quadratic function looks like this. A x minus h squared. This is going to be an h right over here, plus k. A is no longer 0. And notice what we did on the graphs. What we did is we used that little, like the previous one was the 2 and the 1, right? We used that one to find that little bottom point. And so in this case, we're going to call it a vertex. Vertex is just hk. That is so easy. Then we have some conditions. If a is greater than 0, that means the graph goes up. If a is less than 0, we haven't done those yet, the graph goes down. And then a is also the multiplier, right? That's how much we go off to the side, and we'll go down. Okay, good there.
Could you say what the sound form is again?
A parentheses x minus h to the second power plus k. All right, good to go there. Here's a small little problem. Our previous example, yeah, that would be good if I went back. Our previous example like this. In an algebra class, do we normally have trinomials that are set like that? X minus 2 to the second plus 1. They're usually set in trinomial form, is that right? So this guy, that's the standard form. You could say quadratic. So let's talk about this here. Quadratic form is f of x is equal to a squared, ax squared plus C, and also we have to say that A is not 0, because if A is 0, then it's a linear form. A has to be at least something. B could be 0, C could be 0, but not A. Okay, guys, real quick here, let's play between the two forms. And let me add one more else in here. I think the book eventually adds it in, but not right away. Something called line of symmetry. It adds, or sometimes called the axes of the parabola. Those two things mean the same thing, but it's really just x is equal to let me think about it here. Let's see. Is h. Yeah, it's just h. It's the little line that goes like this. If the parabola is facing down, it's that little line right there. Sometimes they'll ask for that. Okay, so we did a lot of graphs. We're good? Comfy with the graphs now, Dylan? Yeah, line of symmetry or axis of parabola. Line of symmetry or axis of parabola. All right, guys, warm enough in here a little bit or no? It's still too cold. Abe has the best seat in the house if you're... Okay, so let's go with it here. So line of symmetry or axis of parabola. Other books call it line of symmetry. So instead of graphing, what we want to do is just exercise. Hey, now we're in exercise 1. Find the vertex and axis of parabola. Okay, because that's the way normally trinomials come in, right? Quadratic equations come in like this. It's something squared plus something x plus something. So our little problem is this. If you go back, that's the form we want it into because that tells us what the vertex is. But the form that we have now is this right here. So now the question is, can we go from this one back to the standard form? Let's see. So let's do this. Let's see what I'm going to do. I have to somehow get this to be a perfect square. Do you guys remember from Algebra 1, perfect square trinomials? Do you guys remember those? They were, let's see, they were x squared plus 2x plus 1. Isn't that a perfect, what's that a perfect square of? Perfect square trinomial of what? X plus 1? I think so. Is that right? Let's see. Because if you do x plus 1, another x plus 1, that's squared. That's x. That's another x because the middle is always double, right? And we get ourselves x squared. Okay, how about this one here? X squared plus, I'll go in order. Oh, I don't need the parentheses here. That one. That one. Okay, 8x plus 16. Let's see, what would be the next ones?
X squared plus 10x plus 7.
10x plus 25, right? Because it's the 5 that's being doubled. 5 times 2 is 10. 5 times 5, or 5 squared, is 25. And we get x plus 4 squared, x plus 5 squared. Are we good there? Cool. Okay, so here's what I want to do. I want to create inside here a perfect square trinomial. So first thing is let's separate a few things out. Let's separate the 7 and move it all the way out here and leave a little bit of space. And let's start in our parenthesis here. Next is whenever we do this process, notice all the ones that we have over here only have x squared. So how can we get inside the parenthesis just to be an x squared only? Factor out of 2, I like that. Factor out of 2, now I have x squared plus, anybody? 4x, thank you. Little bit of space there, plus 7. Oh, I think so, because we have it on the side here. What do we need to add in this guy to make a perfect square trinomial? 4, because it's this guy here. This will be adding a 4, and if you want to put in a different color, just so I know that, hey, we're adding a 4 in. I'm going to put a plus 4. That's going to make a perfect x plus 2 squared. Ooh, hold on. Can we just willy-nilly add 4 whenever we like? If we're going to add and there's an equal sign, we better subtract the same amount so that it's the same, right? But we can't subtract because this is f of x on this side. So what we're going to do is we're going to go over here. We're going to subtract over here. What do we subtract to balance everything out? Not a 4. Why an 8, Maddie? Yeah, this little 2 on the outside, technically there's a multiplier of 2 here. So technically you're adding an 8. Therefore, you're going to be subtracting an 8 to balance things out. Are we good? Maybe I can use the black ink. It might show up better. What do you guys say? Okay, so I think I got this here. I think it's 2 on the outside. Abe said x plus 2 squared. Perfecto. And the 7 minus 8 is a negative 1. Can you give me the vertex? Perfect. It's the opposite of this guy. It's exactly this one. Oh, and how come it's opposite of the other one?
Because it's a minus of a positive, which is just a minus of a minus, and then, or then in the parentheses, and then it's plus of it, and then it's a plus of k, and it's a minus 1, which means it's just a minus times.
Perfect. Okay. The other way you would say it is we go back to our formula. Does our formula have a plus or minus inside it?
It's a minus, so it's the same thing as subtracting -2.
So
you need -2 for each.
Perfect. Yep. Okay. It's a minus in the formula. So we think of opposite or we think of subtracting. What are we subtracting? Perfect. Okay. Can you guys do one by yourself? Just real quick here. Practice. On your mark, get set. Oh, that's why I'm using this guy here. Can we add in a little something here? That'll be A, part A. Part B. Let me pick one for you guys to try.
What exactly are we solving for? I missed that part.
We are trying to figure out the vertex. So real quick here, this is our formula that we find vertex. That's the quick way to find the vertex. It's just minus h and k. What we are given usually in mathematics, we're given quadratic form. We're given those usually. So we want to be able to convert that form to the other form in order to figure out the vertex. It's all yours to try this one.
No.
So we should do it. Let's see.
Yeah,
Ah, no,
Get that chart back up.
Yeah, that's right, plus seven.
Plus 7x plus 1.
this one.
Yeah, that chart. I just want to know if we could write it on the
I
other
got
one.
a 10.
Or if I should just like write them down real quick. I should probably write those down.
We should have it written down, huh? So the next time.
Is there a top one? It's x squared plus 2x, right?
X squared plus 2x plus 1, yeah. We have ourselves a little problem.
Oh,
Because
that's a 2x?
let's see, talk to me. How many of you guys are writing down the perfect square trinomials? Yeah. Because what happens here is that number is a 7. It's not an 8. That is no fun.
A 7 or 2.
The answer is
Sorry,
negative
that's-
4, negative 15.
Ah,
It's a 7.
it's a 7.
Okay.
I'll make my 7s with the dash, so we know this the difference here. All right, so that first one, actually, we should do this one together. That first one was just to get you guys started. And I told you guys to do it by yourself just to confuse Abe, because that's cool. So notice the little numbers here. There's a 2x, it's a 4x, is that right? 6x, 8x, 10x. All of them are even numbers for these perfect square trinomials. Bummer, and then Mr. Ngiev, don't mess with us like that. How come you give us?
Either add or subtract.
So now the question,
Could you do that, or could you like multiply it by 2 so that you have like a 14x and then find the perfect square of
I
that?
think Landon's getting to something here. Notice that, yeah,
Because then you can find the perfect square to that.
when we did the 5 to get the 10, didn't we multiply by 2?
Yeah.
Okay, so hold on. If we just have the 10, how do we get back to 5? We can just divide it by 2, is that right? Oh, and look at this little relationship. This is interesting. So if we take 10, we divide it by 2, we get a 5. We take this 5, we square it to get that guy. We're good? So 8 divided by 2 gets me a 4. Squared, does it give me a 16? Yes, I like it. And then it works all the time, and there's never time it doesn't work. So I'm good. Now what do we do here with the 7? Well, first of all, we gotta leave some space and set up our little parenthesis. Dun, dun, dun. So in order to get our interesting form here, we're gonna take a 7, we're gonna divide it by 2. Is that right? That's 3.5, but actually I'll just leave it as 7. Can I just leave it as 7/2? I'm going to square it. Anybody tell me what's the square form of 7/2?
7. 8. No, squared. No.
49 over 4. I like it. So we're going to add 49 over 4 over here. To balance things out, we are going to subtract. Any multipliers in front? No. So it's just exactly the subtraction of 49 over 4.
Why did we divide 2 by 7?
Sure. The reason why we divided by 2 is because we see this little pattern happening. Since in order to get the 10, we multiply 5 by 2. So if we go in reverse, we just divide out the 2. Because remember with parabolas or with quadratics, the number in the middle doubles, right?
So we're just making it sure we can get the perfect square root of it.
And then we just reverse the process that we needed to get there.
Perfect. How many times do we do that in life, right? You do it one way, like, oh, you know, I could just reverse this. Reverse engineer this little process. Okay. This one's a toughie. This one's a toughie here. So how about this? X plus, and I am going to figure out what's the number here then? 3.5 or just 7/2. We'll just leave it at 7/2. Ooh, you guys have to do this one for me. I need 1 minus 49 over 4, which makes I like it. Negative. Cool. Fun. Give me the vertex. What's the
X
vertex?
plus 7 over 2 squared.
Say that again.
Shouldn't that be like a squared after the parentheses?
I think this so. Thank you so much, Dan. All right. Talk to me. Anybody give me a vertex.
What's the vertex again? X plus H, or X
It's x minus h.
minus H?
Uh-huh.
One and then negative 49 over 4.
Because we have x plus 7 halves, right? Then-
Negative 7 halves.
Thank you. Yep, negative 7 halves for the h value and a negative 45 over 4 for the y value. We got our vertex. Oh, you know what we've been forgetting is axes of parabola. And really what that is you just take the h and you bring it down here. It's just going to be the line that divides that parabola straight in half. Do we have time for it? Maybe. Let's start it here. Let's see. So in history of mathematics, this is a pretty long process. Could you imagine having a whole bunch of different numbers? Could you imagine having like a 3 in front over here and then you having to divide out the 3 and then, oh man, that'd be crazy. Let's do one. So gonna make it even more crazier. We good? So 4x squared minus 3x plus 5. I also have to send you guys a homework sheet, is that right? We'll send that to you guys.
You could just like.
Forget about it, yeah, I totally understand.
We would totally understand if we just blanked on it for. how long is left
Like
in it?
a semester?
6 months.
Yeah.
No, four.
That's so long.
All right, let's do this here so we can finish up here.
Stop.
So you guys talk to me. Can we factor out of 4?
I don't know how-
No.
Oh, this is so funky. You guys ready for this?
Can you factor out a
I don't
negative 1?
know. That's my favorite.
We have
Phone answer.
I'm gonna factor out of 4.
Yeah, we're gonna factor out a 4.
Uh-huh.
How are you gonna do that?
Super cool. How about this? So first things first, out of the first term, are we good? Second term, I have a minus 3 there. I'm still gonna factor out of 4. And the way I'm gonna do it is, second 8,
minus 3/4 now.
minus 3/4 x is correct. Because technically, if I multiply the 4 in, the 4s will cancel. Is that right? Awesome. Okay, next. Next is, what do I do here? In order to do here, in order to bring in here.
You divide it by 2, which is negative 3/8, and you square it, and I haven't gotten that. far.
Okay, perfect. We divide by 2, which is technically, Isabel says, just multiplying by 1/2, which makes negative 3/8.
Square it, 6 over 64?
9 over 64?
That is what I meant.
So how about a plus 9 over 64 goes in here? What gets subtracted to balance?
9 over 64. Wait, no.
No.
Hold on.
You can multiply it by.
We have a multiplier by 4, right? So off to the side here, what I'm thinking.
It's
not fun.
No.
The way that you got the 9/64 was you divided the 3/4 by 2, then squared it, right?
Yeah, the negative 3/4 divided by 2 or multiplied by 1/2.
64 is the denominator.
So it's 5 minus,
Wait, no, well, no, because it's.
so you don't, it's times 4, so it's just 3664.
Yeah,
So my 4
because it's
was
the same as
like-
adding 9. It's the same
Doesn't
as
4
adding
go
9
into
over 6.
64?
Yeah.
So what I'm saying, aren't you
This
just
is
multiplying the
exactly-
9?
You can, yeah. You can do the 9 and the 4 multiplied together if you like. You can divide out the 4, whatever you like. Eventually, the final answer, you're still gonna have to reduce ones
Oh.
there. But I'm thinking without having to mess with big numbers here, how many times does 4 go to 64? 16 times?
So it's 9/60, right?
So 9/16 would be easier to deal with. Okay, almost done, almost done. So 4 on the outside. This is going to be, oh, you know what? It's actually the term before you square it. Right, isn't it? Here's your in term all the time, right? It's the term that you got right before you squared it to be adding stuff in. So this would be a minus 3/8. That's cool, squared. And then we got to do this one off to the side here. 69s, this would be 16. 5 times 16. 80.
Wait, how did you get 6?
So common denominator. And we got it by reducing this one right here.
80 minus 9 is 71 over 16.
So it's -4 and 7.
But where did the minus, where did the?
71 over 16.
Ah, good, good. Abe has something. Abe was make it into a mixed number. And here's the fun thing about mathematics. If you're gonna graph it, then you got to change it to mixed number because you want to know where it is on the number line, right? If you're just stating what is the vertex, you can just keep it as 71 over 16 because it's still correct.
Where did the 9/16 come from?
Sure, 9 over 16 came from,
36/64.
Where did that number come from?
it's 9 over 64. We're trying to balance things out, right? But we have a multiplier of 4 over here. So the 4 has to still balance out.
So it's the 4 times 9/64, just simplified.
Yes, And vertex is positive 3/8, good. Negative 71 over 16.
Oh, wow, that's a wacky.
And then the axis.
Imagine graphing that.
And then the axis of parabola is just.
I'm gonna make things simpler. Perfect. I'm gonna make this an axis of parabola instead of putting, I'm gonna put AOP. AOP is equal to
That looks very.
X equals 2. Looks so mathy.
Don't make this graph up.
Yeah, not gonna make you guys graph. That's okay.
X equals 3.
3, it's always
Because it
the
was a negative, but that's a
opposite.
negative.
Uh-huh. Bam. And on a Wednesday, I'll let you guys go 35 seconds earlier.
That's what my-
I thought my